Welcome back, Night Owls. This is Dr. Nighttime, and tonight we're solving a brain teaser from back when I was a kid. This brain teaser deals with finding the prices of each of 5 or 6 items, and it's going to relate to a principle from linear algebra called linear independence, or linear dependence, if that doesn't hold. What we'll find is in these two very similarly formulated problems, one that deals with 5 objects, one that deals with 6, we'll have a number of ways of solving the problem with 5 objects, but there won't be a way of solving it with 6. And so the basic problem statement is this. A store sells packages of fruit. You know the following about the prices. The strawberries plus the oranges cost $7. The oranges plus the bananas cost $8. The bananas plus the limes cost $9. Limes plus blueberries cost $10. And the blueberries from the strawberries back at the beginning cost $11. And the question is, how much does each package of fruit cost? You might be able to tell, I kind of used a color theme throughout this to try to remember which fruits were paired up with which others. Alright. So one method is we could try to compare prices. So we know that the strawberries and the oranges cost 7. The oranges and the bananas cost 8. Notice I'm using a pretty intuitive, first letter method for assigning variables to the prices. With, of course, B representing bananas or blueberries. I have BA for bananas and BL for blueberries. No, these aren't chemical formulas. This is not sulfur, oxygen, and barium. So, no, it's just fruit prices. Anyway, so we look. The strawberries and the oranges cost 7, the bananas and the oranges cost 8, so that means that the bananas have to cost 1 more than the strawberries, right? If I just compare directly. Meanwhile, I can do the same analysis on the bananas, limes, and blueberries. So go back to the originals, but if the bananas plus the limes cost 9, blueberries and limes cost 10, that means that the blueberries have to cost 1 more than the bananas. So blueberries cost 1 more than bananas. Bananas cost 1 more than strawberries. So that means blueberries have to cost 2 more than strawberries. So I have strawberries plus blueberries cost 11. So that means strawberries plus 2 more than the strawberries cost 11. Do some algebra and you get that the strawberries must cost $4.50. And of course, once you have that the strawberries cost $4.50, you can just solve through the rest of them one at a time. And that's one of the first things you'll notice about a problem like this is once you've got one of them, you can get the others one at a time. Alright. Now I said that with a 6 fruit case it wasn't going to work out so well. So let's see what happens. So in the 6 fruit case, I'm going to add a 6th fruit. This one will correspond to the color purple. So we'll have strawberries and oranges are 7, just like they were before. Everything's the same as it was before, up until it's now, instead of blueberries and strawberries costing 11, it's going to be blueberries and grapes costing 11. And grapes and strawberries combined will cost 12. Alright, so let's try that same approach of comparing the prices of fruits. So we say strawberries and oranges cost 7, and oranges and bananas cost 8. That means bananas must cost 1 more than strawberries. And we do the same thing as we did before. The blueberries cost 1 more than the bananas, but this time we get that the strawberries cost 1 more than the blueberries. Because we say blueberries and grapes cost 11, strawberries and grapes cost 12, so strawberries cost 1 more than blueberries. So we get strawberries cost 1 more than blueberries, which cost 1 more than the bananas, which cost 1 more than strawberries. Which means that strawberries cost 3 more than themselves, which is an impossibility. So we know something doesn't add up here. Let's take another look here. What if we ask the question, how much would it cost to buy all the fruits, 1 package of each fruit? So you look at the 6 fruit case. I've now sort of color-coded the rules that I have, or the facts that I have. So if I look at these 3 in blue, strawberries plus oranges cost 7, bananas plus limes cost 9, blueberries plus grapes cost 11. So if I buy each of those 3 deals, then I'm buying 1 package of each fruit, and that's going to cost 27. Then I look at the three red lines. Right? Oranges and bananas cost 8, limes and blueberries cost 10, grapes and strawberries cost 12. If I add those up, I've also bought one of each of the 6 types, packages of fruit. That way I've got them costing 30. So on the one hand, I've got all 6 fruits costing 27, and on the other hand, I've got all 6 costing 30. So we get that there's an impossibility here. And so we would actually have to change that last line just to make it solvable. Right? We know that if we just look at these first 5 lines, we can conclude that, just from lines 1, 3, and 5, we can conclude that all 6 together cost 27. If we know that oranges, bananas, limes, and blueberries combined cost 18, right, from lines 2 and 4, then that means we would know that this has to be a 9, that grapes plus strawberries would have to cost 9. This concept is called linear dependence. This last equation depends on the other 5 that came before it. Once we know these 5 rules, we know exactly how much the grapes and the strawberries have to cost. So if we put anything other than $9 in this spot, we'll have a contradiction, just like we saw before, where we did some math and we saw that the strawberries had to cost 3 more than themselves, which was impossible. If we say that they cost 9, right, what we already know that they cost, then we have the opposite problem. We have what's called an underdetermined system. We have what looks like enough equations, right? If we have 6 unknowns, the rule is however many unknowns you have, you need that many equations, but not if one of your equations can be determined from the others. And what we'll find is that this is an underdetermined system and that there will be numerous solutions. But let's try changing the problem to make it solvable. There's no paradox anymore, but we still run into a problem that we can't solve it. So just like before, we have the bananas costing 1 more than the strawberries, right? Because strawberries and oranges cost 7, bananas and oranges cost 8. So that means bananas have to cost 1 more than strawberries. And then bananas and limes cost 9, limes and blueberries cost 10, so blueberries have to cost 1 more than bananas. Blueberries and grapes cost 11, grapes and strawberries cost 9, so strawberries have to cost 2 less than blueberries. So what we get, strawberries cost 2 less than blueberries, blueberries cost 1 more than bananas, bananas cost 1 more than strawberries. When we combine those to try to get a solution, instead what we get is that the strawberries cost what the strawberries cost. It's not wrong, but it's a tautology. A tautology is a statement that must be true by definition. We haven't learned anything, and so that conclusion doesn't help us. And so we find that we still don't have a way of solving this system and figuring out how much each one costs. Now, with this notion where we ask ourselves how much does one of each fruit cost, that actually leads to what can be a faster way of coming up with a solution. So an alternate approach, let's do the 5-fruit version where we know there's a solution. What if we add up all the listed prices? That would get us the prices of 2 of each fruit. Right? If we go back to the rules, if we add up strawberries and oranges, plus oranges and bananas, plus bananas and limes, etc., we add these all up, we would get 2 of each package of fruit. Add up these prices, we get that 2 of each fruit cost 45. Meanwhile, if we add up the first and third equations, so strawberries and oranges cost 7, bananas and limes cost 9. Together those cost 16. Well, if 2 of each fruit cost 45, and 1 of each of the first 4 fruits cost 16, so 2 of each fruit costs 45, that means 1 of each fruit costs $22.50. We subtract off these 16 from the first 4 fruits to get that the blueberries, the ones left over, have to cost $6.50. Right? If 2 of each of all 5 costs $45, 1 of each of all 5 costs $22.50. We know strawberries, oranges, bananas, and limes cost $16 from just looking at the first and third rules. So the remaining blueberries have to cost $6.50. And you can plug those back in. You can plug that $6.50 back in and solve it the same way we did before. But if we try that on the 6-fruit version, you can get that 2 of each fruit under that new rule would get you 54, right? Adding up all 6 lines. So 1 of each fruit would cost 27, or 1 package of each fruit would cost 27. But there's no way of combining those rules to isolate for only 1 fruit or for all but 1 fruit. So again, this approach can't be used to solve this problem that I'll say is unsolvable. So now, we're going to try an approach that is not usually recommended, but when all else fails, sometimes you can learn something from it. We know that if we had the price of 1 of the 6 fruits, then we'd be able to solve it. So let's try guessing a price for 1 of the fruits. And so I'd like you, on your own, to guess a price for 1 of these. Guess a price for the strawberries. And then see, well, if the strawberries and oranges cost 7, how much do the oranges need to cost? And go on through and just see if with your initial guess, see if you get the same price for the strawberries that your initial guess was. Right? If you just go through, you guess something for the strawberries that tells you what the oranges would need to be. You use what that is for the oranges, see what the bananas are, and go through. So I'll give you a moment to work on it on your own. And pause the video here. And when you're ready, just unpause. And we'll continue from there. Oh, you're back. Oh, pardon me. So you tried with your guess, and I bet your guess probably worked. Now, I'm going to show you my guess. I guessed that maybe the strawberries cost $3.47. That probably wasn't your guess, but that was my guess. And so if the strawberries cost $3.47, and the strawberries and oranges together cost 7, that means the oranges have to cost $3.53. Which means that the bananas would have to cost $4.47. Bananas and limes cost 9, so limes would cost $4.53. Plug that into the next equation, limes and blueberries cost 10, so the blueberries would cost $5.47, which means the grapes would cost $5.53, and the strawberries would cost $3.47. It comes out to 9, right? It works. My initial guess and my final guess matched. Or if I plug in my initial guess at the end, I get everything working. Now, if I knew that your guess worked, no matter what you guessed, and I'm reasonably certain you didn't guess $3.47, as you probably figured out, it turns out every guess is going to work. This has to do with the system being what's called underdetermined. Right, where it looks like we have 6 different equations, but really we have 5 equations and another one that we knew had to be true. Let's see what happens if we try this on the 5-fruit problem, where there's only one solution. So we know, we've solved before that the strawberries have to cost $4.50. Let's pretend we didn't know that, and just guess that the strawberries cost $3. I'll stick back to a whole number when I'm not trying to show that even an outlandish guess works out. Right? So if the strawberries cost 3, the oranges would have to cost 7. Sorry, no, the oranges would have to cost 4, because strawberries plus the oranges cost 7. If the oranges cost 4, the bananas have to cost 4. If the bananas cost 4, the limes cost 5. If the limes cost 5, the blueberries cost 5. If the blueberries cost 5, you could either say, then either the blueberries cost 5 and we guess that the strawberries cost 3, so that gets us 8 when we need an 11. We're off by 3. Or we could say, blueberries cost 5, but strawberries cost 6. And so strawberries simultaneously cost 3 and 6. our guess was off by 3, or our initial price for the strawberries and our calculated price for the strawberries ended up being off by 3. For this to work, they have to match. So, alright, we guessed, and as usual, guessing doesn't get us an exact answer. What happens if we move our guess by 1? So we adjust our guess. Now we guess that the strawberries, instead of costing 3, suppose that the strawberries cost 4. Now we get that the oranges cost 3. Bananas cost 5. Limes cost 4. Blueberries cost 6. And blueberries plus strawberries equals 11. That either gets us 6 plus 4 gets us 10, so we've gone from being off by 3 to off by 1. Or strawberries initially costed 4, and we say that our final calculated cost for the strawberries is 5. They need to match. They're off by 1. But we figured out that when we adjust by 1, the difference between the guesses shifts by 2. Which means we can now aim our guess. We need to move our guess by 0.5 more in order for the gap between them to shift by this 1. And so that's what we do. Now that we know where to aim our guess, let's see what happens. We'll guess $4.50. Now it's a more educated guess because we were able to aim the guess. So we start with the strawberries costing $4.50. Strawberries plus oranges cost 7. That tells us oranges cost $2.50. Oranges and bananas cost 8. That tells us bananas cost $5.50. Bananas and limes cost 9. That tells us limes cost $3.50. Limes and blueberries cost 10. That tells us blueberries cost $6.50. And then we either say $6.50 plus $4.50, blueberries plus strawberries does equal 11, as it should, or blueberries plus strawberries equal 11. $6.50 plus strawberries is 11, so strawberries is $4.50, the same as our initial guess. Either way, it works. So what happens if we try that adjustment procedure for the 6-fruit case? So we know that it works when the strawberries cost $4.47. So if we start with we know it works when the strawberries cost $3.47. If we adjust by 1, maybe the strawberries cost $4.47. Then we get the oranges cost $2.53, bananas cost $4.47, limes cost $3.53, blueberries cost $6.47, grapes cost $4.53, strawberries again cost $4.47. So again, the initial and final guesses match. And what we get is that our initial guess, if our initial guess moves up by 1, instead of our calculated guess moving down by 1, closing the gap, or opening the gap if we move in the wrong direction, then we get that our initial and calculated guesses move together. So if they started off matching, they'll always match. If they started off differing by some amount, then they'll always differ by that same amount. And again, that will happen with these underdetermined systems. So because we knew that last equation, or we could calculate that last equation with the grapes and the strawberries from knowing the first 5, then our system was not linearly dependent. Or sorry, no, our system was linearly dependent. It was not linearly independent. And in those cases, you won't be able to solve even when you have the correct number of equations. As always, if you found this useful or entertaining and like the way I explain things, and want to arrange private lessons, click the link in the description. And until next time, this is Dr. Nighttime wishing you a good night.